as we mentioned earlier, you can find the area of a regular polygon by using the formula. Area is equal to 1/2 times the apothem times the perimeter. Actually, if you look at the figure, so this is a regular hexagon, right? And we said that, each of these 6 triangles is actually an isosceles triangle. So if you know the formula for a triangle, which is base times height divided by 2, you could use that as well. But since there's 6 triangles altogether, so get area of 1 and then just multiply it by 6. So what we're going to look at next is study how to use this formula in finding the area of a regular polygon. So in this example, we have a regular nonagon. So that means it has 9 sides. The nonagon is inscribed in a circle with a radius of 4 units. Find the area of the nonagon. So we know that from the formula, we need to know the following information. The length of the apothem, which we don't know yet this time, and the perimeter. Okay, so to find the perimeter, we need to know the length of one side, right? And then multiply that by 9. Okay, so how are we going to find the missing information? I want to zoom in to this triangle over here. Okay, so let me zoom in on that right triangle. Yeah. So that's L. This is M, where the right angle is. And this is K. So we know that LK is 4, right? So first, can we figure out the measure of this angle? If yes, how? Okay, so we know that it has 9 sides. So what we're going to do is we divide 360 by 9, because 9 sides means 9 central angles as well. So that's going to be 40, right? But that 40 is for the whole central angle. So it's this whole thing right here. So to get the angle that we want here, just split that in half. So that means this is 20. There we go. So since L and K are complementary, this must be 70, right? Well, how does that help? So the apothem is represented by the length of segment LN. So this is the apothem, and this is half of one side, right? We'll call that X. So how do we find the apothem? So to find apothem, we're actually going to use, one of your trig ratios, right? So you can use either sine or cosine. If you use cosine, then it's going to be adjacent over hypotenuse. Or if you want to use sine, it could be opposite over hypotenuse. So whichever you prefer. I'm going to use cosine. So I go cosine of 20 degrees is equal to adjacent, which is A, and then hypotenuse, which is 4. So solving for A, I get 4 times cosine 20, because you multiply both sides by 4. Okay, so let's do that in the calculator. 4 cosine 20 decimals. So 4 times cosine 20. So approximately it's 3.8 if you round that off to the nearest tenth. So A is it's approximately 3.8. Okay, so now we have the apothem. The next thing that we need to find is x. So to find x, well, we now have the length of the apothem, so you can do Pythagorean theorem. Or since we try to, avoid using computed values, meaning values that, we probably made mistakes. I'm not saying our answer is wrong, but we know for sure that these two angles are complementary, so we can verify that they're right. Add them up, equal to 180. So if you're, more confident about that, then just think of a method that you can use without using your initial computed value. So how can I find x in this case? We can use another trig ratio, right? So to find x, how about let's use sine 20. So sine of 20 is equal to opposite over hypotenuse, which is 4. So that's, I don't know if you've forgotten that. Let me write it down over here. I taught you the shortcut before, right? It's SOHCAHTOA. So sine of an angle, an acute angle, is equal to opposite, which is x, right? The opposite of 20 is x, over the hypotenuse, which is 4. So that means if you solve for x, so x is equal to 4 times sine of 20. So let's get what x is approximately equal to. 4 times, we're using sine now. So sine 20, so that's 1.4 to the nearest 10, right? So going back here, it's going to be 1.4. Okay. Now remember, your x is only 1/2 of a side, right? So that means the whole, line segment. So this means line segment KJ has length 2.8. So now let's try to find the area by using the formula. So area is equal to 1/2. Your A or apothem was 3.8. And then it has 9 sides. You're going to multiply that. Let me just use parentheses. Okay, you're going to multiply that to 2.8, which is the length of one side of the regular nonagon. So if you multiply all of that, you got 1/2 times 3.8 times 9 times 2.8. Okay, so the correct answer is, or the final answer is around 47.9 square units. So that's the area. So let me write it down over here. We got approximately 47.9. Okay, and take note I said like approximately because we rounded off intermediate values. Like we rounded this off, right? We rounded off this value again. And we use those to find the total area. Now, if you want to use the exact values, which is the ideal case, so you can rewrite the formula as area is equal to 1/2. Your apothem was 4 cosine 20, and then the perimeter is 9 times. Now you have to double this value, right? Because this is x. So you have to multiply that by 2 in order to get the whole side. So pretty much it's 9 times 2 times 4 sine 20. 4 sine 20. So this will become 1/2 4 cosine 20. This will become 9 times 8 is 72 sine 20. So altogether now, that's 4 divided by 2 is 2 times 72. So that will be 144 cosine 20 sine 20. So if you enter this in your calculator, the result will be, this will be, I forgot, I didn't remember, 46.28 or 46.3. So this will be 46.3. There you go. So you see that difference between when you're using intermediate values versus when you're using the actual values, right? All the way to the final answer. So that's why in the past assignments that I've been giving you, for those that have answer banks or word banks, my instruction was, choose the best approximation for the area of the figure or something like that. Because, yeah, I know some of you are using rounded off intermediate values and finding the correct answer. So I'm not saying this method is preferred over the other or this gives you a wrong result. I mean, algebraically, they're all correct. It's just that this may result to some, rounding of errors or differences. Alright, so that's an example of how to find areas of regular polygons.